Okay, for the first video of the week, we have first a review of recursion, which is, well, a recursive function is a function defined using itself. So it is it is a technique that we often use when we want to solve a problem that can be broken down into a smaller size of the relatively same problem. So, ano ibig sabihin ng problem na yan? So, for example, this is the factorial function. So, a factorial function is yung product ng lahat ng integers smaller than that number. So, for example, n factorial is equal to n times n minus 1, n minus 2, and so on and so forth. So for example, if we want to get 10 factorial, we have 10 times 9 times 8 times so on and so forth times 2 times 1. So since ganito yung form ng ating factorial function, we can actually simplify this part over here into 9 factorial. So yung 10 factorial natin, pwede natin siyang i-write as 10 times 9 factorial. So yung original problem natin, which is 10 factorial, kaya natin siyang i-write to a similar problem na smaller yung input, like 9 factorial. So, in code, you can define a function, the factorial of n, and yung value na i-return natin is n times the factorial of n minus 1. So, yun, that is our factorial function. However, if you try to run this, ayan, medyo color red, parang merong kulang sa ating work. So, kung titignan nyo ito, sabi niya is maximum recursion depth exceeded. That is because hindi tumitigil yung function natin. So, factorial of n, let's just write f, kasi ang haba sulat na factorial. So, if for example, kinol natin si f of, para mabilis lang, f of 3, this calls f of 2, and then this calls f of 1, and then this calls f of 0, and then f of 0 calls f of negative 1. So dapat actually tayo umabot dito. However, because of how we defined our function, tuloy-tuloy lang siya. So, i-call naman ito si f of negative 2. So, anong kulang dito sa factorial function na to? So, yung kulang natin ay yung tinatawag natin na base case, or the case wherein we stop our recursion. So, for example, for this factorial function, we have, yun nga, kung balik natin, factorial of 3, and then that will call factorial of 2, which will call factorial of 1. But wait, pag factorial of 1, 1 is not greater than 1, so hindi tayo pupunta dito, pupunta tayo dito sa baba. Ito tinatawag natin na base case. So, usually, sa ating mga recursive functions, ganun siya. Meron tayong isang case na recursive yung definition, and may isang case dapat tayo na tinatawag base case na for sure dapat mag-terminate. So, pagdating ng f of 1, okay na si f of 1, return 1. I-multiply natin k2, and then multiply natin k3, so may 6. So, in this case, magra-run na yung ating program. Try natin dito. I-play natin siya actually. So, the factorial of 10 is 3,628,800. Then, pwede nyo rin itong galawin. For example, factorial of 15 can get this big number, basically. So, so that is our review for a recursive function. Now, moving on, ang actual focus ng ating discussion should be the analysis of our recursive functions. And first up, well, of course, ang tinakal pa lang naman natin sa course is time complexity. So how do we determine the time complexity of a recursive function? So we first start with what we call the recurrence relation. So yung time it takes for our recursive function, T of n, for example, for the recursive function, is the time ng function using n-1 as input plus some constant runtime for the actual operations na ginagawa dito. So yung if at saka yung multiplication, yun yung sinisimbolo ng ating C1. So yung other functions. And then yung T of n-1, siya yung equivalent ng ating recursive call. So can actually map it. So for example, yung time complexity nitong line na to, or nitong function call na to, is this one. And then all the other, everything else, so yung pag-check ng conditional and yung pag-multiply, we can attribute this to C1. So ano naman yung C2? So si C2, siya yung sa base case, or yung constant, no? Evaluate ng base case. So yun. So gumamit na ako ng arbitrary constants just to say na constant sila, but hindi pa rin. So dito lang lahat. So from the recurrence relation, ano yung gagawin natin next? So actually may dalawang methods. For this video, we'll just tackle the first one, which is the substitution method. So sa substitution method, medyo tricky siya. It's understandable na hindi siya makuha agad. Pero for this method, we are looking for a pattern when we try to expand our recurrence relation. So gusto kasi natin makuha or matanggal yung expression na to sa ating time para ma-apply natin yung ating big O analysis. So starting from yung ating recurrence relation na hindi base case, we can expand itong nasa loob. So saan equal si T of n minus 1? Equal siya kay T of n minus 2 plus C1. So pag in-expand natin ito, yung T of n minus 1, ito yung makuha natin term. And then pwede natin siyang, pwede natin i-combine yung like terms. So yung dalawang C1 may into C1, and then T of n minus 2 na to. And note na, si T of n minus 1 equal siya dito. So yung left-hand side natin stays the same as T of n. Then we can expand this further. So T of n minus 3 plus C1 plus 2C1, which will leave us with T of n minus 3 plus 3C1. And then you can predict, pag in-expand natin yung Tn minus 3 na term, magiging Tn minus 4 to, and magiging plus 4C1 tayo dito sa right, or dun sa ating constant na term. So, lahat ng mga to, lahat ng expressions na to equal kay T of n. So, can we think of a general expression for T of n na hindi gumagamit ng numbers? So, basically, nakikita natin dito kung ano yung minumultiply natin kay C1, yun yung sinusubtract natin kay n dito sa loob. So, what we can do is, we can substitute k doon sa loob. So, imbis na n minus 5, may n minus k. And we know that based on our patterns over here, letter k, or yung the same coefficient k, yung multiply natin kay C1. So further on sa course, banda sa dulo, you'll know that can actually prove this to be true through using what we call proof by induction. Pero for now, well, mukha naman sumusunod yung pattern. Pag kukunin natin si t of n minus 6, alam natin na 6c1 yung nasa dulo. So for now, pwedeng maniwala na tayo na tama siya. So, ayun. So we have an expression for t of n that doesn't involve yung number na 1, or basically yung expression natin sa loob, we can change this to anything we want to be if we assign a value for k. So, ito, that when n equals 1, yung ating t of n, hindi na siya equal kay t of n minus 1 plus c1, nagiging c2 na siya. So, if we let k equals negative n minus 1, k equals n minus 1, we can replace this. So, si k, naging n minus 1. And yung k din natin dito, naging n minus 1. So, this first term simplifies to t of 1. And then the second term is n minus 1 times c. So, ayun, kaya nating tanggalin yung t1 term na to. Alam natin na equal lang siya kay c2. And then this can retain its form. So, basically, ang ginawa natin, naglagay tayo ng arbitrary variable para i-define yung nasa loob ng recursive na call, such that we can predict yung ating pattern at the kth recursive call, essentially. And then because of that, we can simplify yung nasa loob dito to be equal to the time complex, or to be equal to the expression for the base case. So, yung t of n minus k, ginawa natin siyang t of 1. And by doing so, we can replace it with c2. Pero, tandaan, since si k exists outside nitong function call or nitong recursive call, nakamultiply siya kay constant 1, magre-retain yun. Pati siya, magbabago at magiging n minus 1. Therefore, pagdating natin sa pagkuha ng big O ng t of n natin, we can use this expression and we can get that the time complexity of our function, factorial of n, is O of n, or linear with respect dun sa ating input. So, ayun. So, I think there will be more examples regarding this. Well, pero dun muna tayo sa next video, which will explain the next method, which is the recursion tree method. So this that will be all for this video. See you next time.